Well, just
yeah. So we can begin with our introduction of our.
Thanks for the invitation, and we are very happy to share our thoughts and also be part of the Autoware community. My name is Gijs Dubbelman. I'm associate professor here at TU Eindhoven. I'm heading the Mobile Perception Systems Lab, and our research interest is mainly in data-driven perception techniques. So for mobile systems, mainly vehicles, but could also be trucks, drones, all kinds of vehicles that need to perceive and understand their environment with AI. And we have our own, let's say, research platform, a vehicle that is based on Autoware, and I will show you a bit more about it. We also work a lot together with our local industry on these topics, and they're mainly on mapping and localization for self-driving vehicles. Currently, we have a new initiative at our university where we take different labs that are related to automated driving across the different faculties and unite them in one automated driving lab, or AUDRI, the AUDRI lab. And I will show a few slides on that, and that will also include all the latest things that we and mainly Anbeshan has done with Autoware. Maybe Anbeshan, you can share a bit.
Yeah, so I'm Anbeshan Das. I'm a researcher at TU Eindhoven, and I'm also a PhD candidate. I mainly work on automated driving related projects, and my research topic is on post-graph-based optimization for vehicle localization and map making.
Okay, I think you should be able to see my slides. Is that correct?
Yeah, we can see. I think we are seeing your presenter view. You can swap the view.
Oh, how do I indeed? Well, just a second. Share. Screen 2. Share. Now you should see the correct view. Yeah. Okay. I won't take too much of your time, but I want to highlight some of our initiatives. So. As said, at the TU, we're now investing in a cross-faculty and multidisciplinary research lab for automated driving. And the purpose of this lab is to mainly provide the research infrastructure to the labs across the university where then more the academic research will take place. So what kind of infrastructure will we be providing? We will be providing an automated driving rapid prototyping platform. I'll have some pictures of that later. Its software is based on Autoware. Our campus will serve as a testing environment, low speeds, so let's say up to 30 kilometers per hour. And then off our campus, we will also make a digital twin environment and link it to AWSim, so that we can truly have, let's say, also a digital environment to test and to do research in, and maybe even train our AI agents in the future. So everything that we develop in AUDRI is meant to be open science and open source. It also holds for all our, let's say, extensions to Autoware or the data. We all want to open source that soon. This is a little bit our view on automated driving. So we focus on this level 4 automated driving, and together with our industry partners, so maybe it's good to mention here, in Eindhoven we have several OEMs, vehicle manufacturers, but mainly for trucks and public transport, buses. So we no passenger cars, but let's say large vehicles. And with these industry partners, we mainly focus on these kinds of operational design domains, going from yard automation, public transport, and maybe in the future also robot taxi and shuttles. Now for that, of course, yeah, you all know the conditioning and so on and the fallback. But let's say for this yard automation, public transport, we are using Autoware, you could say this modular-based system where certain components are model-based, certain components are data-driven AI, they're integrated in the software framework to do a certain task. But in our more academic research, we are also focusing more towards this end-to-end AI, where we believe that you will still have a modular system, so let's say a system of deep neural networks, but that can be jointly trained to do the automated driving task. Okay, on to the next slide. Of course, this presentation is not only for you, but also for those that don't know Autoware, but you guys know Autoware, so I can skip these. This is our vehicle. Well, it's a Toyota Prius. It has a nice fake roof on top that you can easily lift, mount all kinds of sensors on it. It has a very big PC in the back with powerful GPUs, but also embedded computers, RTK, GPS, everything. So this is really a very mature research platform, and it also has a drive-by-wire system. So this is a little bit how the architecture looks like. I guess, again, it doesn't come as a surprise to you. We have a, let's say, an off-the-shelf Prius. We can control its drive-by-wire system via COM. We use for now the CoE AI hardware for this, but in the future we might want to go for more mature automotive-grade hardware. On top of that runs Autoware, and inside Autoware there our own modules live for our research. This is a view of the sensors that are currently on the radar. So we have 360 long-range, medium-range LiDAR, stereo camera to the front, imaging radars, also in a 360-degree setup. What is currently not on the car are also thermal imaging cameras and all kinds of cameras. We have those. And in the back is well, our compute unit, also an RTK GPS system. The GPS system we only use as a reference system, only to record data and able to reference the data. During automated driving, the RTK system is not used. Okay, then we have invested, and mainly Andersjan has invested a lot in our own mapping pipeline. So for environments like these, this is actually the DAF test track. We can ourselves record the raw point clouds, create different map layers as required for the Autoware stack and also for the extensions that we have on top of Autoware. This is something that we are very proud of. This is actually a DAF truck, so really a 4-ton truck driving fully automated using NDT, let's say Autoware, on the DAF test track. Again, you are familiar with these kinds of videos, but here you see the truck, the live point cloud, the point clouds in the map, and by doing so, it can localize and drive a trajectory over the environment. I think by now, how many kilometers did they already test? I think already a couple of hundreds. Hundreds of kilometers were already tested. The NDT algorithm and the LiDAR localization. This uses 2 LiDARs mounted at the top left and top right rear view mirrors of the truck, and it works very well. Here you see, well, this may be not so interesting, but here you see our setup inside the DAF truck, where you over here see the visualization again of the NDT and the truck doing automated reverse docking maneuvers. And as far as we know, this is very accurate, and it is able to park the truck almost in any kind of given circumstances, but except for fog. So dense fog is really a problem for the LiDARs, and then the system doesn't work. But also considering that there are no sensors on the trailer, and the angular accuracy that you need at the truck to kind of reversely dock a truck with a trailer really shows the accuracy and the robustness of this NDT algorithm under live conditions. That's very nice. Same movies, I'll skip it. This is very recent. I just mentioned that the LiDAR is not working correctly under heavy fog. That's why we're also now testing with the 360 radar solution. And the radar point cloud is referenced to the LiDAR point cloud map. And this is really something from previous week. Now we need to look at probably with a bit more detail. Where's my mouse pointer?
You can see.
Where is the vehicle now? Oh, it's going to zoom in.
Yes.
This is not a fancy video. But you see the vehicle driving, our TUE Prius, driving over the campus, oh, there it is, and over an automated trajectory using LiDAR, a map and a radar-based setup on the car. And potentially this should be more robust to very dense fog conditions and so on. And also the radar doesn't have any moving parts, so it should also be, in that aspect, also be more robust. This is now on our TUE Prius using Autoware, but we'll also then test these same technologies on the DAF truck and later also on public transport buses together with our other partner VDL. All right, so where are we now? So we have a Prius with core Autoware functionality. We are already testing these things with our OEMs. We tested it up to 30 kilometers per hour, but DAF already tested it on the test track up to 80 kilometers per hour. We have for various test sites already Autoware compatible maps. So for our campus, the DAF test track, the automotive campus. We have a pipeline for new test tracks. And well, we even have another vehicle Prius that is for sale, but that's not so relevant to you guys, but maybe to others. So what do we want to do the coming year? We want to go to a full stack Autoware implementation. So what we currently have active is, let's say, driving over the predefined trajectories, doing some route planning and path planning, but we want to enable a full stack Autoware implementation. We want to improve the safety certification of our drive-by-wire system. We want to create a digital twin of our TUE campus and link it to Autoware Simulator. And of course, all with the purpose to, let's say, support our research in AI, but also in 3D radar-based perception and localization. And we want to make an effort to really start open sourcing our data code models to the general public. Here in Europe, and I think it was nice that you mentioned it, Raoul, because we have many European projects where we always actively work together with partners, and it would also help us a lot if we know here in Europe which are the partners that are using Autoware and how can we jointly collaborate in getting research funding via the European Commission. And these are some of the, let's say, the automotive partners that we are working with, that include DAF and VDL, but also Valeo, Electrobit, NXP, and I think we have a quite extensive network in that direction. Yeah, I think that was a gist of our research here at the TUE Eindhoven and our usage of Autoware. And I must say that Autoware is really one of the cornerstones, one of the most important pillars of being able to do this higher TRL level research. And we're also happy to contribute back to the community. So yeah, I'll leave it at that.
Oh, fantastic.
Yeah.
I think this is an Anvishan. I think this is very, very nice to see, and you presented it so efficiently that you have a very fit vehicle and your campus is actually being used as an experimental ground. And I think this is exactly like the state in which most of the Autoware CoE members are, that they have a vehicle, it's able to do, let's say, like this trajectory following, and then but our research ambitions are much more than,
of course,
than just the basic functionality that Autoware provides outside of the box. So let me just open it up to everyone else. If you have questions, you've seen some very interesting demonstrations here, and and also give you an opportunity to welcome our friends from Eindhoven.
Maybe,
yeah. Hey guys, welcome guys, and fascinating presentation. Greece, I just wanted to ask you a question. Are you guys looking at all into any, mixed terrain environments, any kind of agriculture or non-traditional sort of driving environments?
We do, although I must say all our Autoware platforms is just for public road. But our colleagues, they are also more active in other kinds of environments with different kind of robotic platforms. Yeah, yeah, indeed. And we're certainly also interested to kind of go in those directions. Yeah.
Yeah. Okay, that's great. And I just also wanted to add, given your interests and stuff, obviously you've got the relationship here with the CoE. If you haven't already, I would encourage you to look at some of the working groups with Autoware, like mapping and perception and these sort of things as well.
I think, I'm not sure, Anders, but you were joining one of those, right?
Localization.
The localization one we are active in. Yeah. Yeah.
I think David is also there.
Oh, yeah, he knows. Oh, yeah.
I think he doesn't know me, but
Okay. Great. Yeah, it would maybe be nice to maybe do a quick round of introduction so that we also learn to know everybody in the group. Yeah.
Great idea. Let's do that. Yeah. Yeah, maybe we'll start with David and then move on.
Yeah. Sure. I'm a little bit of an anomaly, guys, in the group. I'm here for industry, but I work a lot with universities. So I'm with Pix Moving, and Pix makes a RoboBus, a skateboard developer chassis, a number of other different products. So Alex Carballo is also one of our chief science advisors. He'll introduce himself shortly here with Gifu Nagoya University. But as Raul knows, I try and stay active and bring a little bit of an industry focus. And I'm also very focused on translational technology, things that can be used, put in front of customers, in short, find sustainable revenue models and these sorts of things. Yep. Thanks.
Thanks.
Oh, I'm also co-chair of the OpenAD Kit working group. And please feel free to come by sometime. There, we're more focused on architecture within Autoware, containerization, modularization, like breaking perception out as an example. So you could upload the container. We do some demos around over-the-air updates and things like that as well. And also very interested in maybe doing some V2X demos, in jiving with the work that William Hay, who's also on the call, is head of the API working group, where they're doing some interesting stuff around V2X. So, yep. Thanks, guys, and welcome.
I'll have a look at it. Thanks. Yeah.
Yeah, maybe.
Can I pick? Can I pick who goes next, Raul? Can I just lateral it?
Yeah, right, let's do that. Let's do that. Everyone pick the next person.
All right, I'm gonna go with William, and William lateral to Alex. Move forward, William.
Okay, all right. Hi, everyone. Hi, my name is William. I am a fourth-year PhD student in Dr. Xi's lab. We're at University of Delaware. Our current research focus at University of Delaware within Autoware is one is the digital twin, and the other is V2X. So the overarching goal is to investigate Autoware and then to make it safer and more responsive, more real time, etc. So similar to TUE, we've already built a digital twin of our campus. So I was the lead architect and programmer on that. So yeah, and right now we're actually writing a proposal to build such an infrastructure so that we can open it up to more members in the community. Just like David said, I'm also co-leading the API work group. In the API work group, right now the focus is integrating V2X into Autoware, and the second is how to enable V2X or cellular software update within within Autoware.
Oh yeah, okay, that's amazing. Yeah, thanks. Well, we might reach out to you for our digital twin of the campus to get maybe some tips and tricks, things to do and things not to do. Yeah.
Yeah, of course. And I know at UPenn, Pojan, he has made his own twin. He has made their own digital twin around the Pennovation Lab. So you should definitely talk to Pojan about that as well. Yeah.
Okay, cool. Thanks. Yeah.
Yeah. That's it for me. Yeah. And then I'll pass the mic to Dr. Carballo.
Hello, this is Alex. I am an associate professor at Gifu University and also a guest professor at Nagoya University, both in Japan. Also connected with Tier 4 company, the one that is running things behind Autoware,
Yeah.
Autoware Foundation, etc. And yeah, also associated with Pix Moving. So a few. What I'm doing basically is the topic of driving behavior. So how people, passengers particularly, react to autonomous vehicles.
Oh, yeah.
For example, the topic of subjective risk. Are you happy with the behavior of the car, the controllers, and everything? So we work on research in the past, trying to personalize an NPC and try to add subjective information to reduce the perception of risk. On a related topic, we are bringing that into the topic of driving under adverse weather conditions. I was very interested to see your presentation about driving under foggy conditions and how the 3D array of the 360-degree configuration of radars was very useful in the topic of localization, that you're doing the efforts with object detection and so on. So we are also doing a similar effort, combining multiple sensors, including thermal cameras and so on. So perhaps there's a possibility to connect on that topic. And recently, and that could be interesting also, particularly in your case. So we're trying to bring Autoware into different domain in the topic of automated surface vehicles. So leaving the road and going into the ocean for rescue operations.
Oh,
So,
okay.
yeah.
Yeah. Oh, cool.
That's it.
Yeah, thanks.
Thank you.
Great. We can go to Ehsan and then Johannes.
Thank you. Hi, everyone. My name is Ehsan Hashemi. I'm an associate prof at the University of Alberta in Canada. And my research is mostly focused on perception using sensor networks in the ITS setting, and also decision-making under uncertainty. In my lab, we have developed, again, a digital twin around the campus and also in downtown Edmonton to include traffic items and also main features of the environment. And for that, we are using, again, that platform to study decision-making under uncertainty in the dynamic environment.
Okay, interesting. Yeah. There's also this whole V2X, X2V kind of thing comes into play.
Yes, with V2X communication for two purposes. The first one is to enhance the reliability of the perception, accuracy of the perception. And second is to enhance the reliability of decision.
Yeah, collaborative perception, those kinds of paradigms. Yeah. Cool, thanks.
Thank you, Johannes.
And Ehsan is also the chair of the ITSC, and he has been doing this humongous job to pull up big conference that.
We will be present. Myself, probably not, but some of our PhDs will go. So.
Okay, good.
Thanks for your efforts.
Yeah, thank you. Good to have you here in Edmonton. Yeah, and I would say that was only one experience in whole life.
I can imagine.
Look forward to meeting you all here.
Okay. Hi, everyone. My name is Johannes. I'm an assistant professor from the Technical University of Munich here in Germany, so in close proximity to Eindhoven, and my research is focusing on software development for autonomous systems, focusing heavily on motion planning and control. And I was Raul's postdoc for 2 years, so worked in the USA, and I know this group now for a very long time, heavily engaged with Tier 4 and Autoware, also part of the strategic planning committee, and happy to have you on board.
Thanks. Nice to meet you.
And next, Mike.
Hi, folks. My name is Mike Carlizzi. I am Professor Raul's project manager. I help to support schedule and scope and the many balls in the air. So I'm here to support all of you as well. So nice to meet y'all.
Yeah, same here.
Thanks, Mike. So we'll go to Armin and then Gordon and then CJ.
Okay. So welcome, guys. My name is Armin. I'm from Humda Lab. We are a research lab located in Budapest, Hungary. So also not so far from you when we are having global picture. We are focusing on autonomous racing. Therefore, we are engaged with the Autoware mainly on, as of today, on the AV for EV platform, so with the go-karts. Nevertheless, we also do have access to for a big proving ground. So if you have a necessity for even for high-speed testing with trucks, even that's also possible at all locations. So just let us know.
Cool.
And welcome.
Yeah. No, I don't think so. Somebody.
All right. So yes, maybe I guess the one is so Abhijit, I see you.
Hey, good morning, everyone.
Hey.
Hi. So my name is Abhijit Sarkar. I'm a senior research associate at Virginia Tech Transportation Institute. I also lead the computer vision and machine learning group here. My focus is mostly on multimodal perception. So VTTI actually collects a lot of naturalistic data. So we are collecting around multiple projects. I think that multi-million miles of data from different combination of sensor suite. These data are generally like on road and means real road and real driver data. My role mostly is to supervise the perception stack for the system, as well as making some efficient processing. And parallelly, I'm also interested in driver monitoring and also also the integrity of this kind of sensor processing. So.
Okay, interesting. Is that data also meant to be open source, or is that more for shared, let's say?
Data will be, means I think that's the goal, to share the data. The only problem is that given the volume of the data, it's in the petabyte range of data. Often means that's very difficult to share. But yes, means I believe that in a year or year and a half, more data I can probably bring to the table for the group to work on.
Amazing, yeah. We will send some SSDs or take a plane to.
Yeah, I just paid to double our LFS space on GitHub, so. All right, and so I see CJ and then James Yang.
Okay, maybe I can go first.
Go ahead.
Okay, yeah, my name's James Young. I also recently joined this group. This is my second meeting, so I'm also new here. I'm a professor at Xi'an Jiaotong University in China. I focus on simulator. So we work with Carla team to make more robust Carla with new features. So right now, yeah, our version works smoothly with Autoware, and also we are going to have new UE5 available. So if you want to try these new features, other than UE5 will be probably released in mid-September, but other features like editor and other things, you can contact me.
Okay, nice.
And also, yeah, we collaborate with a group that open sourced middleware that can replace ROS. It's called Dora. It's on GitHub. So if you want to try some new middleware, then you can also contact me.
Okay.
Yeah.
But the simulator that you are working on is based on Carla and not necessarily AWSim.
Yeah, so Carla, yeah, we work closely with Carla team. So we solve the stability issue. So right now, Carla, like if you run, so we support distributed simulator simulation and and some other issues like right now, Carla probably if you run for one day, it's crashed several times. We saw that problem.
Yeah, indeed. And we also have certain experience there. Yeah. Okay, thanks.
Right, that's one of the, yeah.
Okay, yeah.
Yeah, and then lastly, I guess, Christian John. I'm the chairman of the Strategic Planning Committee in the Autoware Foundation, so I've been working very closely with Raul to develop the Autoware CoE ecosystem. And I look forward to working with you and your team on, engaging the community. Please, don't hesitate to reach out to me if there's anything that we can help with from the Autoware Foundation side. So welcome.
Okay, thanks. Yeah, same here.
We have, I think, Mitsude-san, and please let me know if I'm missing anyone else here, just to give a quick intro.
Hello, I'm Ryusuke Mitsume. Sorry, I don't have my camera today, but so I'm the chair of technical steering committee and kind of help out with people contributing to Autoware and the technical aspect. So if you have any issues around kind of contribution, or if you have any issues around kind of using Autoware as well, I'm here to help. So nice to meet you all.
Same here. Thanks.
Great, great. So I think that covers us going around the room, and we have a good 20 minutes, for open discussion. So I think, as we saw in the discussion, everyone is engaged with Autoware, from a certain perspective. I would say, but they're using multiple facets, right? So say, for example, James is looking at is working on really, amazing simulation capability that is not just, at a academic level only, but at a, almost like a production level, where it is useful in running, scalable scenarios. So the other aspect I see is that, there are different kind of tools out there, right? So there is Carla for certain type of, research. There is AWSim, and then, within the CoE, we are looking at some, kind of off-street driving cases like that, right? So I shared a link to the slides. I don't really want to show any more slides today, but I think you'll see there, we have one is the, our part of the CoE's mission for the first year was to build, these open source reference platforms, right, that are running Autoware, but everything is open source, right? So like the one platform was the go-kart platform, and that's also been adopted by Humda and then by Armin's colleague Attila. And so in the next meeting, Attila will present his his sort of company has taken over the contract from Humda to actually build out the AV for EV, basically electric go-kart that is running Autoware and runs a full stack of Autoware essentially, and that's a full open vehicle, right? It's unlike, say, like a Prius or a Lincoln, where you're retrofitting a vehicle. Here this is drive-by-wire, everything is open. And so I think there is so that allows us to then say, okay, well, as part of the CoE, we will have like a way to even have a shop to purchase these vehicles for research and have a research partner that will enable getting new platforms, right? So and also, as David Valmroth has posted, the Pix Moving is another platform, because we want to have a variety of possible platforms. A second direction that the CoE had gone into was in looking at like off-road driving. And so we've built a 1/5 scale platform that is still under construction, but essentially to explore what it is to use our Autoware in more wild terrain or multi-terrain environments, and how do you then extend planning and control and along with the end-to-end perception pipeline. So it forces us to move away from this kind of follow the line kind of driving on the street to something in a wilder or a less capable environment, or a more challenging environment. Another aspect we look at is running Autoware on forklifts in warehouses. And so the idea is that there are off-street applications, but each one requires like a branch of Autoware. So the one main topic I wanted to go over today now is that, given that, everyone has covered their research interests, is that, this year, basically the year starting from September to the next August, is really on defining with each CoE member, or even maybe small groups of teams of the CoE members, an engagement project where, how can Autoware help you? And then where Autoware CoE is your partner in that. And that's basically the resources of the CoE, including Pojen, who's a very skilled robotics systems engineer, having the support of Mitsudome-san on the Autoware side of things. He is basically the architect behind, lots of Autoware code. That is, his fingerprints are all over the code, over the architecture, and the future roadmap. And so we have the main people from there, and then also the support of CJ in terms of building strategic partnerships, in terms of building these into projects. So we have a kind of good critical mass of EU based institutions, so for EU based engagements, and US institutions, but it does not have to just be geographic like that, right? So I think what would be useful is maybe we can start with from maybe let's start with Johannes, since he has a very sort of well-defined project with Edgar as to how they are using Autoware, and then so each will, and then we will follow up this meeting. Pojen and I will follow up with each one of y'all to define like a project that if it makes sense, right? I think we don't want to do this we want to do this in a very organic and natural manner, that where Autoware can help you. So maybe Johannes, you can give us an example of how y'all are using Autoware, and then how what is your roadmap going forward, and then we can pass the mic around the room to say, okay, well, how can what is your roadmap? And so ideally the whole idea is that we have a good critical mass of researchers who are fairly competent across perception, planning, control, across software engineering for autonomous vehicles. Then this is more power to you without any additional cost to bootstrap everything. Yeah, please go ahead.
Yeah, thank you, Raul. So what we here at TU Munich, we also have a research vehicle similar as you have one in Eindhoven. And this research vehicle is used by us to apply some new technologies, methods in the field of autonomous driving we developed. Unfortunately, we cannot do everything, right? And therefore, we are using Autoware, number one, as a backbone to drive this vehicle, but also number two, as a development platform where we can integrate our software applications, right? For example, we developed here a new motion planning framework for autonomous driving in street scenarios. So we are using Autoware, and we are developing our software, and then we are replacing the Autoware modules with them. So we integrate basically our software in the Autoware universe, or like in the Autoware software stack. So what we then can do, we give it back to the community, so other researchers also can use that kind of software we developed. Then, of course, we heavily engage with Autoware on presentations, communities, conferences. For example, now, as you have heard, ITC in Canada, which is happening very soon, but also at IEEE, IROS, or ICRA, all these conferences around the world where we also present what Autoware can do, and then move it to different platforms. But that's just one example, and maybe others can also share what they are doing with Autoware. Or if you have questions, then go ahead and ask.
Yeah, so I think what we'll do in like one-on-one follow-up discussions with every CoE member is just understand the roadmap, and then see how essentially for Autoware, I would say, like there is no membership fee for academic members. For premium industry members, it is 50K to 100K, having people be full-time involved. I would say the only currency really, in terms of the cost of a membership is really contributions back to Autoware. So we improve the ecosystem, and we are, actually making it a richer ecosystem. And next, I'd like to invite Josh Garcia from UC Irvine. And Josh has been doing a lot of exciting work with Alfred Chen on the security aspects, and really has found a lot of bugs in Autoware. And but Josh will talk about one of the projects that is Autoware supported, and how we can also get involved in that.
Okay, thank you so much, Raul. Beyond the software security aspect, we do a lot of software testing and debugging research for Autoware. So as Raul mentioned, we've studied generating tests and identifying bugs and fixing them, and we're hoping to move that into even automatically repairing bugs in Autoware. But beyond that, and I think this is a good opportunity for me to share my screen, is we are...
Give me a sec.
Thank you.
Yeah, go ahead.
All right. So, okay. You can, okay, so you should be able to see this figure now. We have some a little bit of NSF funding that we recently were awarded in order to plan and prototype. So this is part of a research infrastructure grant, essentially a platform for making it easier to conduct like software testing and analysis research, software debugging research for autonomous driving systems. Since as you all see, like a bunch of you have not only the autonomous vehicle, but you also have the tracks, you have your own simulators, and this creates this challenge of like fragmentation, if you will. And makes it harder to potentially reuse, replicate, reproduce all sorts of research. And in our case, we're particularly interested in software testing and debugging research. And so we want to be able to take, for example, all the different digital twins, simulators, all the testing and analysis and debugging techniques that have been increasingly growing in the research literature. And also, although Autoware has become essentially the center of this at this point, because it's not only open source, but as you can see here and from our interactions with Autoware developers, Tier 4 developers, it's really open platform, an open community. Being able to integrate those and then also take all sorts of different data sets out there, whether those are the HD maps, the test suites. So for example, Autoware has this great CI/CD platform out of the Autoware Evaluator, and all sorts of different reproducible scenarios, and just make it so that integrating and testing these. So for example, I could take an arbitrary one of your simulators and have even multiple autonomous vehicles running like Autoware or even Apollo, test and analyze them, show that we're really improving the safety, security, like even comfort aspects of Autoware. And so beyond that, part of this has also been we are working on running a workshop at the top conference for software engineering research, so ICSE, It's going to be in Canada next year, and we've been on one of the workshops accepted, and we're hoping to get also additional funding to invite people to at least hopefully help pay for some of the travel registration, so that we can, although this is potentially more general to other aspects of software engineering, we want to focus on building that kind of platform that I showed you there, that is potentially cloud-based, figuring out the requirements, what's maybe, for example, members of the Autoware Centers of Excellence or Autoware Foundation might want at a platform like this, and not just, for example, the software engineering community. And of course, I'm interested in also other communities you belong to, whether that's a more transportation-oriented, robotics-oriented, and so forth. Yeah, and we're looking for all sorts of different paper submissions and kinds of participation for these reasons. So thank you so much for everyone's time. And I'm open to questions, ideas about this. So please feel free to, I guess, ask now if there's time, or reach out to me separately, so that hopefully this synergizes with the kinds of work and interests that you're doing.
Thanks a lot, Josh. If you could share the link to that, that would be great.
Oh
And
yeah,
I
absolutely.
think we'll have CoE members who definitely be interested in that. And it's good that it's in 25, so we have time to plan out. Yeah, and I think I think, this would also, for CoE members interested in the software engineering aspects, this is, the venue for that, right? So, all right. So I think we are, closing to the end of the hour. So I think with what we will plan out, for the rest of the semester going forward and rest of the year is really, we'll keep you updated with, we have the ITSC conference coming up. We'll also have like Autoware running on F110 in Niagara, in another smart mobility conference. We'll share all of that in a newsletter update, and then we also will have Autoware on F110 in IROS in October, and finally the last and then there is another Autoware on F110 in Boston that will happen in November, and then finally in December we'll have the competition in Milan at the CDC conference, the Control and Decisions conference. And so essentially every month there are lots of events happening. There are also Autoware meetups. Recently there was meetup in California at the ARM headquarters. Maybe CJ, you can give a brief update on that. And then what we'll do is, as we come to the end of the hour, we'll follow up with each one of you all to have a one-on-one and really, have a meeting of the minds on, how can Autoware CoE help you with your research, and then how can we go forward together on that. Yeah, I'll just let CJ give a little brief update on, where Autoware as a software-defined vehicles, approach is going forward with ARM and the industry ecosystem.
Yeah, thanks, Raul. So as Raul mentioned, we've been working very closely with ARM, which initiated the SOAP SIG. So what they're trying to do there is standardize a framework for how software is developed for software-defined vehicles in the future. So introduction of things like microservices architecture, abstraction of hardware to enable portability of software applications across many different hardware architectures. And most recently, the introduction of mixed critical orchestration capabilities. So in automotive, you obviously have safety critical applications. How do you ensure that those safety critical functions in the software are running on the necessary full stack implementation of an RTOS with a safety capable processor and so forth. So all of these are kind of part of the framework that they're enabling in the SOFI SIG, and then we've worked closely with them now to take Autoware and integrate it into that framework. It's still work ongoing, but we hope to have in September, or actually this month, we are in September now, the first release of the containerization of Autoware, so breaking up perception, planning, control, functionality, and so on into the SOFI framework, each of these functions in a different container. And that'll be something that we will make available to the CoE to start to leverage. And I think that will be a great framework for the teams to kind of introduce new functionality into Autoware that's kind of aligned already with this concept of developing for software-defined vehicles. The other interesting thing that ARM is doing is their next generation silicon IP, which is based on their V9 architecture. They already enable virtual prototyping capabilities in the cloud to develop software, run it on these virtual prototypes before the silicon is even available. And that's something, again, that we're also working closely to enable Autoware running on these virtual prototypes that you can use to validate for the next generation of silicons for processors like NVIDIA Thor is already a V9 architecture and so forth. So let me know if you have any questions. Happy to follow up offline if you'd like to know any more details. Thanks, Raul.
Cool. Thanks, CJ. All right, so we'll end our call today, and then thank you, and it was really great to meet our new friends from Eindhoven, and we welcome you back. And so we'll have our follow-ups before we meet again in a month, and we'll have a much more focused engagement through the rest of the year. Thank you, and have a great week ahead, everyone.
Yeah, thank you.
Bye, everyone.
Thanks, everybody. Bye.
Thanks,
See you next
everyone.
time.
Thank you.
Thank you. Thank you. Bye-bye.